Hi, and welcome to MSM Solutions YouTube channel, Quality Systems, Quality People. We have touched on some of the basics on the stats that gets used in the lab. And in this video, we continue in the same pattern and just add on some very common everyday terms or calculations that we tend to do in the lab and just explain them in very simple terms and see what actually are we calculating and how are we supposed to go about interpreting data from this. We have spoken about relative standard deviation, where we use to check if a multiple reading on an analysis is within an acceptable limit, whatever the limit has been set at. So you would do 3 or more readings and then calculate your RSD and look at that number to see if it's within your spec, and then you will then accept or reject your results. Another thing that we tend to do is sometimes we do duplicate measurement or even twin stream measurements. That will be when sometimes it will be when it was sampled, you had 2 samples taken, so an A sample and a B sample. That would be sort of the twin streaming act. Or you have 1 sample but you do duplicate measurement in it. So from the 1 samples, you make 2 analyses. At the end of the analysis, you then have to compare these 2 values. And what we then would use is percentage difference. You would look at what is the percentage difference between these 2 values so that you can say that if this is acceptable or not. So how do we calculate percentage difference? You would first look for the difference, the absolute difference between the 2 values that you're doing. So the absolute difference between, say, A and B, you say A minus B and you get a number. You divide that by the average of the 2 numbers. So A plus B divided by 2, since we're working with 2 numbers. And then you multiply that by 100 to get a percentage difference. That will be percentage difference. Sometimes we're not looking for percentage difference, but we're looking for relative difference. So when you're doing relative difference, you do relative to a number. So this would happen, say you have repeated your analysis. You had the first value and now you do a repeat analysis. And now you want to compare this new value with the first value that you did to see what is the difference between now my original result and my repeated result. What you then do for relative difference, because remember this is relative to original, you will take this new number, subtract the old number and divide by the old number. So basically what you do, you take in the value that you want to compare with, you subtract it from whatever your reference value is and you divide it by the reference. We also do this when we calculate relative difference to our CRM value. So this is the same way that you would calculate, and obviously to get a percentage, you'll multiply this by 100. Sometimes you will see that people don't use the percentage difference or even the relative difference, but they use HARD, HARD, half absolute relative difference. Mostly you would see in some geological sampling activities that you see them mentioning HARD. But what HARD does is it calculates the absolute difference between the 2 numbers divided by the sum of those 2 numbers. So it doesn't necessarily use, compared to our percentage difference where we were using the average of the 2 numbers, but it takes just the sum, and then you will then multiply this by 100 to express it as a percentage. And then you would then compare this to see if it's within acceptable limits or not. And this number would normally, from previous data, you would have calculated like for this sample type, this is what is acceptable, and for a different sample type, this is what is acceptable as my hard value. You can even draw graphs to just show a pattern of what's happening, between your different pairs, your different duplicates, or your twin stream activity, whatever you are. So you're able to actually arrange these from smallest to largest and actually draw a hard graph on it and see better what your precision is all about. So we've touched on comparing mainly for precision, your repeatability rate, and even reproducibility, where we were talking about relative difference between your first sample and a repeated number, and you're just comparing those numbers. But in the lab, we also talk about comparing to other labs, where we're now trying to see how is our method comparing to other independent labs, people that do something similar to what we do, but not necessarily using our instruments or our method, but they're analyzing the same or type. They might be using the same instrument, but a different brand, and it done in a completely different way. You will then talk about ZScore. When you look at your PT round robin results, you'll see that they've calculated and compared your number to ZScore. So what is a ZScore? A Z-score is also called a standard score. It gives you an idea of how far you are from a mean for a set of data points. More technically speaking, it means how many standard deviation below or above the population mean your raw score is. A Z-score can be placed on a normal distribution curve, and you will then look at Z-score ranges from 3 standard deviation to -3 standard deviation of your normal curve. And you would then say that if your results are outside those plus and -3 standard deviation, the results are unacceptable. Other times you would even reduce that. You'll find some PT saying that the acceptable limit is within plus or -2 Z-score, and then anything outside that would need to be investigated. So how do we calculate Z-score? So it's quite a simple calculation. To calculate the Z-score, you take your result, you subtract it from the population mean, and you divide it by the population standard deviation. That will then give you a Z-score relative to that individual score. So that's how each and every Z-score will then be calculated. It is your number subtracted by the population mean divided by the population standard deviation. It will give you a Z-score, meaning this is how far you are from the mean. Another equation or calculation that is sometimes used but not very common is the Howard's equation. Howard's equation was suggested by Howard and others in the 1980s by looking at the relationship between interlaboratory reproducibility and the concentration of the compound being analyzed. This is sometimes used for some labs with intra-laboratory comparison, not necessarily only inter, but this was actually originally done for inter-laboratory comparison. And an empirical formula was calculated or suggested for this relationship. And as you can see, this is dependent on the concentration of the analyte, and it will significantly change as that concentration changes. However, over the years, there's been some limitation with this equation, and a modified Howard's equation was then suggested and has been used depending on the kind of data that one is looking at. Another way that lab would look at their data within this Howard's equation is look at whole rate or the Howard's ratio. They would calculate the Howard ratio and look at the number. And if the number is between 0.5 and 2, this is normally considered acceptable. And based on historical data, the lab might even reduce that significantly and say what is acceptable for this particular lab or this particular analysis is maybe a value less than 1. And they would then say that is where their ratio needs to be. And every time they do an analysis, they will look at that number. So this is another equation that can be used, but should then, depending on the data set you're looking at, you will then decide on how it best suits you or what ratio would be acceptable for your particular application. So we've spoken about comparing two numbers using relative standard deviation. We could be comparing two numbers from the same analysis, your duplicate, could be comparing from repeat analysis, or even comparing to other labs where we were looking at Z-scores. When we spoke of Z-scores, we spoke about normal distribution. We're talking about 2 and 3 standard deviation. So in the next video, we need to just tap in a little bit on what is this normal distribution. You've heard of normal distribution, you've heard of the bell-shaped curve, you've heard of Gaussian curve or Gaussian graph, and we need to understand this probability theory. Where does it all come from and how do we use it? Because most of the time we talk of 95% confidence limit, or we talk of 1, 2, or 3 standard deviations when we're looking at our QC data. We're always referencing back to a normal distribution curve or a Gaussian curve. We then need to just unpack it a bit and say, what is this and how does it help us or even make our lives more complicated? See you in the next video.